All right, so this is 7.2, part 2. Part 2. So today we're going to be solving word problems. They're going to be our exponential growth and decay word problems. So we're going to use this formula here to help us solve word problems. In the word problems, we're always going to need to find what our initial amount is. So that's our A. So it's whatever we start with. The number of time periods, so it'll usually say like 10 years. That would be our T. So T is the amount of years. And then our rate, which is going to be like a percent, but it's the decimal version of the percent. So rate or growth is always going to be the decimal of the percent. So let's say we had 25%. What would be the decimal version of it?
.05.
So if our decimal's here in 25, we just move it twice, so it would be 0.25. What about if we had 10%? What would the decimal version of it be?
Wait, what is the B?
What?
What is that little B that you write?
Oh, that's the percent.
Oh.
It's just kind of attached here. How do we write the decimal version of 10%? 0.1. Perfect. We would just move our decimal 2 places. And what about if we had 3%? What's the decimal version of 3%? Awesome. 0.03. So we move our decimal 2 places, so we would need to include that 0 there. So the rate, our R, is always the decimal version of the percent. Always move it twice. So in all of these problems, we need to find our A, our T, and our R. And then we just plug it into this formula here. So you invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in the account after 6 years? So we need to find our starting amount, the time, and the rate. So what's our starting amount? 1,000. What's our time? How many years? 6 years. So T is equal to 6. And then what's our rate? 5%, but we want the decimal version of 5. 0.05. Now we plug it into our formula. So our amount that we're trying to find, so capital A, is equal to our starting amount. I'm going to write the formula up here so we see it. So A is equal to A times 1 plus R to the power of T. So our starting amount is 1,000. So that goes out front. Then we have 1 plus R, so 1 plus 0.05. And then raised to the power of T, which our T is 6. Now we want to put this into our calculator. It's super important when evaluating this that we follow PEMDAS. PEMDAS. We got to follow our order of operations. What should we do first? 1 plus 0.05. So 1 plus 0.05 would be 1.05. So we got to do a parentheses first. What should we do next? the exponent. So in your calculator, you guys need to know how to do this. So make sure you actually practice doing this before the test or the quiz. So we want to evaluate this into our calculator. If you're doing it in the iPhone calculator, the buttons that you click would be, I'm going to write it on the side here. So we put 1.05. Then there's a button that's X with the exponent Y. So then you would click that and then 6. So this is how you do it in the iPhone calculator. If you have an actual calculator, you would put 1.05 and then there's like a little up arrow button and then 6. That's X raised to the power of Y. So that's the button that you click in your calculator. We got 1.34, then it's like 009. What are we doing next after we find that? What do we do with that 1,000? Multiply. So we're multiplying what we just got by 1,000. So in your calculator, keep that whole number in there, everything that you just found, and multiply it by 1,000. $40.09. When we're dealing with money, we want to keep 2 decimal places.
So like, if this was the test and you didn't put the 009, you would get like, you would probably get it wrong.
You'd get partial credit. You got to keep your decimal places here, that way they show up in your answer here.
How do you know how many you put?
Just keep it in your calculator. Like if you just evaluate this in your calculator, keep it, don't clear it in your calculator, then just multiply it by 1,000. Or you could write it down, but make sure you write down all the decimal places that it shows you. Alright, next we have continuously compounded interest. So this is the same idea as the last one, but just a different formula because these are continuously compounded. So the problem, the word problem, will say when it's continuously compounded, that means you use this formula. The other one will say like a certain amount of years or something. This will say continuously compounded. And each time you see continuously compounded, use this formula. So super important keyword, continuously compounded. So the principal is our starting amount. That's just like the A that we had in the last one. T is our time in years, and R is our annual interest rate. So it is the decimal of the percent. So same type of things we're finding in this one, just a different formula. So in our example here, suppose you won a contest at the start of 5th grade that deposited $3,000 in an account that pays 5% annual interest compounded continuously. So we see that word, those words, compounded continuously, so we're never going to use the second formula. How much will you have in the account when you enter high school 4 years later? Express the answer to the nearest dollar. So compounded continuously, our formula is P times E to the power of RT. Yes. E is a button in your calculator. So E is like, we're going to use that E in our calculator. It's just a button. Let's go back to our calculator and look at it. All right, so we need to find our P, our R, and our T. So what is our starting amount? $3,000. What is our rate? 5%, but the decimal version, which would be 0.05. Awesome. And then what's our time? 4 years. So we plug everything in. We have 3,000 times E to the power of R, so 0.05 times T.
Wait, Wait, isn't it for 5% is 0.05?
Well, yeah, the 0 would be out here. So 0.05, but you don't need to include that 0. I mean, you could put it outside if you want to. All right, so first thing we want to do here is evaluate this up top here. So 0.05 times 4. Point. What do you think we have to do next?
We multiply 0.5.
We're multiplying these up here because our formula up here is r times t. So we have to multiply this first. So just think about it as your r and t are in parentheses, and you want to do these parentheses first before you do that exponent. So now we can do the exponent. So we're going to put this into our calculator. We want to click that E button and then click the x raised to the power of y because we're dealing with an exponent, and then 0.2. So these are the buttons you're going to push into your calculator in that order. What do we get? So 0.54 and more numbers. Keep it in your calculator so we get the most exact answer. What do we need to do next? Multiply it by 3,000. So keep whatever you got here, all that in your calculator, and multiply it by 3,000. Yeah, I think we're a little bit off here. So let's fix that. Our e raised to the 0.2 power. $1.221 sounds more accurate.
Yeah, something like that.
And then we can multiply this times 3,000. So we get 3,664.28 or 0.208, so we could round up to 0.1. But this question says to round your answer to the nearest dollar. So how should we leave our answer? Which is the nearest dollar here? Where should we stop? 3,664. Perfect. So this is our answer. So just be careful when putting it into the calculator. There's also in the phone calculator, I think in like a regular calculator as well, but there's an e raised to the power of x button. So if you click 0.2 and then click that e raised to the power of x, you can do it this way also. So these are two ways of putting it in the calculator. All right, so here, how much should you invest in an account that pays 6% annual interest compounded continuously if you want exactly $8,000 after 4 years? Oh, we're going to skip this one. The first two questions from your homework, you're going to use the first formula that we did. So A is equal to A times 1 plus R raised to the power of T. What's your little a here? What is that? The starting amount. So starting amount. What's your R? The rate, but it has to be the decimal. And then what's the T? well, just in general, T is years. So you're going to use that formula for 8 and 9. And then for 10 and 11, you use the other one that's compounded continuously. So that's P times E raised to the power of RT. PERT is what we call it.